Right. Look at this slide, students. So there is a watermelon. Imagine this watermelon is of the exactly the spherical shape, not the oval shape, right? No egg shape. Imagine, assume this watermelon is having assume the spherical shape of the watermelon. So when you cut it like this, this part, this is called a mirror. See, this is the part you get it. For this part, if you polish, see, this is the part I have received. If you polish it like this, that means reflected part, reflecting part is this side. So this is called reflecting surface, and that this is called is the polished surface. And what kind of mirror it has become? What kind of mirror it has become? So this is a concave mirror, my dear students. I hope you understand. So this is the concave mirror, my dear students, like this. Imagine a spherical shaped sphere, a watermelon, for example. Instead of watermelon, here a hollow glass sphere. It is cut like this, and one side is polished, another side is reflecting surface. So that is called a concave mirror, and vice versa. All right. Now, why I have taken this example, you will understand now. Why I have taken this example, you will understand now. And this is the part, this is the concave mirror is a part of a sphere. Yes or no? Students, tell me. So this is the concave mirror is a part of the sphere. This is the sphere, okay? And if you try to assume the sphere, this sphere will have a center, and this sphere will have the radius. I hope you got the point, students. And of course, you take this also, students. You take this also. So this is the convex mirror case also you take, students. Convex mirror case also you take it. So if you extend it and make it the actual sphere, this will have a center of curvature and this will have a radius of curvature, where C and R are center of curvature and radius of curvature. What is that? C and R, center of curvature and radius of curvature. So C is center of curvature and R is radius of curvature. Okay, students. Now, one more point. One more point I would like to explain here. One more point. Observe carefully. This point is very important for the image formation. So the point what we are going to discuss now, what we are going to discuss right now is very important for the image formation, and I'm writing this here. So very important for the image formation by spherical mirrors, whatever it may be. So that may be convex mirror image formations or concave mirror image formations, whatever it may be. The very, very important point we are going to discuss, and that point is that look at here. The hollow glass sphere we have. The hollow glass sphere we have. That is what we have imagined as a watermelon. Imagine it's a hollow. Now, when we cut like this, students, the line, if you draw a line along this cut happened, so that will pass through the center of curvature, isn't it? Student, that will pass through the center of curvature, isn't it? Everybody should respond. Yes. So imagine if you cut like this here, and here also if you draw a line, that line also will pass through the center of curvature. That is important. Imagine this is the sphere, right? So if you cut here and like this, if you cut here, here also the line will be passing through center of curvature. That is important. And if you cut here, here also this line will pass through the center of curvature. That is important. The simple example we are discussing, simple example. Now coming back to our mirrors. So this is our mirror. So imagine a situation. Imagine a situation. Imagine a situation. A light ray is incident here like this. Students, a light ray is incident here like this. And it is similar to the line which is passing through the center of curvature. Understand? Like that. Fine. Now, one more point. Listen. For example, if I incident a light ray like this, students, if I incident a light ray like this, students, it is appear to pass through the center of curvature. Now, I'll draw here. I'll redraw here. I'll redraw here so that the better understanding you'll get it. Better understanding you'll get it. The beautiful concept we are going to discuss right now. Carefully observe, students. Carefully observe. This is what an imaginary line I have drawn here. Students, a light ray is incident here. The beautiful concept I'm telling you. Light ray is incident here, students. We also know that laws of reflection are valid. Yes or no? We also know that the laws of reflections are valid in case of spherical mirrors also. Okay. Loss of reflection means what? Angle of incidence is equal to angle of reflection. Okay, students, at this point, point of incidence is there. You should draw the normal line, right? Listen, the normal line I'm just drawing here. Carefully you observe that normal line will pass through the center of curvature like this. If you draw a line here, that will pass through the center of curvature. If you draw a line here, that will pass through the center of curvature. If you draw a line here, that will pass through the center of curvature. If you draw a line here, that will pass through the center of curvature like this. On this mirror, any line if you draw, that will pass through the center of curvature like this towards the center. Understand? So this line, this line, this line, or this line, or this line, or this line, this line, this line, all are passing through the center of curvature, and similar concept is now. And this is called angle of incidence, students. Angle of reflection also will be there. So this is how the reflected light ray will be moving. This is angle of reflection. So this is called incident ray. Observe carefully. And this is called reflected ray. And this is called the normal line at any point of incidence on the convex mirror or concave mirror. Students writing a statement. Listen. At any point of incidence on a concave mirror and on a convex mirror, the normal line will pass through. Normal line will pass through what? Students, tell me. Normal line will pass through what? Students, normal line will pass through what? Normal line will pass through what? I need the responses. Okay. Normal line will pass through what? Pallavi. Pallavi M. Jadhav. Pallavi M. Jadhav. Please speak out. The normal line will pass through what? Pallavi.
Center of curvature, sir.
Very, very good. The normal line will pass through center of curvature, right? Super.